So, first thing you need to know from this section is what a power is. Does anybody know what a power is?
It's like the little 2 after a number.
Right, that's what the little raised number is called the exponent. The entire thing is the power. So we're going to write it like this. An expression written with an exponent and a base. So the entire expression is called a power. For example, 3 to the power of 2. This is a power. Okay? The base of this power is what? The 3, the bigger number. And that's the factor that you're going to multiply. And the exponent is what?
The 2.
The 2. The exponent represents the number of times you're going to multiply the factor by itself. It's the number of times to multiply the factor by itself. So in this example, the factor is 3, and we need to multiply 3 times itself 2 times. So that would be 3 times 3, which is 9. Yes. It's very important that you understand that 3 to the power of 2 is not the same thing as 3 times 2. Okay? 3 to the power of 2 is 3 times itself 2 times. So that's 3 times 3. So powers are basically repeated multiplication. It's when you're multiplying a number by itself a given number of times. For example, 2 to the power of 3 would be what?
2 times 2.
Yes. 2 times 2 times 2. The numbers in this section are not going to get so big that you need to use a calculator. So you want to continue practicing doing this without a calculator, because on your quiz tomorrow you will not have a calculator. So this one's pretty easy. 2 times 2 is 4. 4 times 2 is 8. So 2 to the power of 3 is 8. You're also going to see fractions raised to powers. For example, 3/4 to the power of 3. You use an exponent to a fraction in the exact same way that you would use an exponent to a whole number. So this literally means 3/4 multiplied times itself 3 times. So just do the numerators and then the denominators. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Good. 4 times 4 is 16 times 4 is 64. Good. Okay, one of the most important things that you will learn in this chapter is about negative bases. So when the number that's in this position is negative, there's one very, very important thing that you need to look at. Okay, the thing that you need to look for is whether or not the base is in parentheses. So let me show you what I mean. If we have -5 in parentheses to the power of 2, when -5 is in parentheses, that means the power of 2 is applying to both the 5 and the negative sign. So not only is the 5 going to repeat 2 times, but the negative sign is going to repeat 2 times as well. So what I mean by that is this would be -5 times -5. We talked about yesterday a negative times a negative is a what? Positive. So -5 times -5 would be what? Positive 25. Now let me show you why that makes a difference. if I had negative 5 to the power of 2 like this, and you notice the negative 5 is not in parentheses. Okay, make sure you're writing all these examples down, please. Okay, that means that the power of 2 only applies to the 5, not to the negative sign. So what that means is the negative sign is not going to repeat. It's just going to stay in the front of your problem. Okay, so this is like saying negative 5 times 5. Notice, the 5 repeats twice, but the negative sign does not. This makes a difference because 5 times 5 is what? 25. But that negative sign still remains there, so now the answer is negative 25, not positive 25. It's really, really important that you pay close attention to this because it will make a big difference in your answers. If the base is in parentheses and it has a negative sign, then repeat the negative sign with all of your factors. If it is not in parentheses, then leave the negative sign in the front. So basically that means if it's not in parentheses, your answer will always be negative, okay, because it's just going to camp out right there at the front. Okay, let's do a couple more examples like that. Okay, so what if we had negative 6 to the power of 2? So what you need to look at is the 6 in parentheses? Is the negative 6 in parentheses? No. So that means that this is the same thing as negative 6 times 6. 6 times 6 is 36. And leave the negative in the front, negative 36. This is like having a negative 1 in front of your multiplication problem. So the exponent 2 applies to the 6, but not to the negative 1. So it's going to remain there no matter what. Okay, you're also going to see some geometric models on your homework. For example, what if I had, I'm going to do the best thing I can to draw it, this 3D box. Okay, and on the box it told me that each side is worth X. And the instructions say, write the power represented by each geometric model. So what power is represented by this 3D model?
Cubed.
Right, cubed, which is to the power of 3. Perfect. Okay, let's go ahead and go on to page 8. The last thing that you have to do, and this tends to be the one that gives us a little bit more trouble, is write powers. So I want you to write writing powers at the top. So we just talked about how to evaluate powers, how to solve them. Now we're gonna write them. So what this section is going to do is it's going to give you a base. It's going to give you a solution, and it's going to give you a base, and you need to figure out the exponent, basically. So the instructions would say something like this. Write each power as a solution. I'm sorry, that's wrong. Write each number as a power of the given base. And then it's going to look something like this. 8 base 2. Now, what I saw a lot of people do last year when this was a question on a quiz or a test, or especially is on the final, is they just wanted to write the answer like this, 2 to the power of 8. Okay? That's not what this question is asking you to do. Okay? What this question is asking you to do is write a power, so write an expression where the base is 2 and the solution is 8. So 2 to the power of what equals 8? So you're given the base, you're given the solution, you need to come up with the exponent. Good. We know that 2 to the power of 3 is 8 because 2 times 2 times 2 is 8. If you don't know that off the top of your head, all you have to do is multiply the base by itself until you get the solution that you're looking for. So my answer is this, 2 to the power of 3. Okay, how about this one? 81 base 3. So you know that the base is 3. You know that the solution is 81. You're trying to come up with the exponent. So you're asking yourself, how many times do I need to multiply 3 by itself to get 81? So 3 times 3 is what? 9. 9 times 3 is what? Okay, keep going. 27 times 3 is 81. So we multiplied 3 1, 2, 3, 4 times. So this would be 3 to the power of what? 4. Okay, let's try one more. Negative 125 base negative 5. Now, on the questions where your base is negative, you need to pay close attention to whether or not you need to put your base in parentheses. Sometimes it doesn't matter. Like in this case, it doesn't really matter because my solution is negative anyway, so it's not going to make a big difference. However, if my base was negative and my solution was positive, then that probably means that it's in parentheses because that's the only way you would get a positive solution. So we know that the base is negative 5. We know that the solution is negative 125, and we need to figure out what exponent to put on negative 5.
Is it 5?
Let's try it. Negative 5 times 5 is what? Negative 25 times 5 is what? So we multiplied 1, 2, 3 times. So the exponent should be the power of 3. Good. So in your composition books, I want you to do a little bit of practice on your own. Open up your textbooks to page 29. And you're just going to do at the bottom of page 8 where you have a little bit more room, you're just going to do questions 9 through 14. When you're finished, page 29, questions 9 through 14.